Hello everyone. Welcome to today's session. Today we will talk about setting up TypeScript with React. Before we dive into the setup and actual code exercises, let's try and understand why do we need TypeScript and React. So React, as we have seen in previous sessions, as well as the React to-do app that we developed, it's highly versatile and flexible library. But with this flexibility, there are some potential pitfalls as well, especially as your application grows. When your application grows, it becomes crucial to manage the types of input output that you want to have from at a component level or the responses that are coming from your services, because as your application scales you will fetch data from multiple sources, you will update that data, you will edit that data, and it becomes very crucial that we know what sort of data is coming out of the API, what are the edits that we are making to it, what is allowed versus what is not allowed. And that's why managing types for your components, props, state, and the API responses becomes very crucial to avoid bugs. So TypeScript provides this as a solution to our React projects. TypeScript is a superset of JavaScript that introduces static types, which means that when we are coding, we define the type of variables, functions, parameters, and return values during the development phase itself. This allows us to catch type related issues early before even we run the code. So before we compile it, your IDE can help you understand what sort of type errors have you introduced with the latest change and how you can correct them. So now let's dive in a little deeper to understand how TypeScript helps with key areas in React. Number one is type safety. Type safety means TypeScript will ensure that the types of variables and functions outputs are exactly as expected. If you try to use the wrong type, TypeScript will throw a compile time error. How would this help? So whenever we create React components, we often receive props from parent components. But without types, it's easy to accidentally pass the wrong prop to the wrong component. TypeScript checks the types of props and will always ensure that we do not pass anything that is incompatible to data components. The second main point is scalability. So what is scalability? This is something that you might be hearing in your projects day in day out. Scalability refers to the ability of a project to grow in complexity and size without becoming unmanageable. So, how can you say a project is scalable? It's a very big application that is very complex, but it's not unmanageable. You can still go in, find the respective components, and make the changes that you need to do. How TypeScript helps here is, as our application grows, keeping track of data structures like props, states, API responses, it will become increasingly difficult. But with TypeScript, we can create these reusable types and use them in multiple places. And we can also create interfaces, providing consistency across our application. This helps reduce the bugs when we are adding any new feature and enables easier collaboration among developers. For example, another developer is responsible for adding a new prop to a component. Once you take an update from the developer, you will immediately understand that the prop is of type string. So, for example, if he added a label, the label is of type string instead of having you pass a children label component. So that clarity comes up. And also, for example, a new API was introduced. What is the data structure of that API? So you can define global types for API responses, ensuring that data structures are consistently handled across our applications. This will reduce errors significantly that originate from the APIs. The next one that we need to be aware of is maintainability. Again, this is something that you might be hearing a lot in your projects. And what does it mean? Maintainability refers to how easy it is to make changes and fix bugs to an existing code base. That is a maintainable code. So for example, you have a bug in your form component today. If the code is not very maintainable, the developer who's onboarded would have to go through a bunch of forms that are in your application, then try to understand if we are creating forms separately and its components are not centralized, and then try to identify the bug. That's not a very maintainable code. But if you've structured your form in a way where you're using the text input box across all the forms, the developer who's onboarded only needs to come to your project, open the components folder, go to form components, and fix the issue with text input. That will fix across all the 20, 30 forms which you have in your application without impacting anything. How TypeScript helps here? So TypeScript improves maintainability by making our code self-documenting. How does it self-document, you might be asking? So the types that we define act as a living documentation. It helps developers to understand data flow without constantly referring to external docs. You go to your component, you hover over the component API, and it tells you what are the inputs, what are the outputs. And that is very clear. If a developer makes a change that breaks an expected type, TypeScript will help you catch it immediately, preventing runtime errors. It will break your compilation, and since we are developing, we'll be able to identify and fix it immediately without impacting other work streams. Example, as I mentioned, when working with a very large team, one developer can update a component and TypeScript will automatically check that no other part of the application that uses that component is broken by the update. So if you introduce a mandatory prop, which you're not passing from anywhere in the application, it will start throwing errors in those appropriate places. We'll see this when we start developing applications. And the last one that we need to cover is developer experience. What is developer experience? Being a developer who's already going through these sessions, you might already know it, but developer experience refers to how easy it is for you to develop a new functionality without getting jumbled up in the boilerplate or having to understand too many things around it. So, whenever you're writing a new component, you want to consume an API, you should get the API's type as a return type. So, it helps you understand what sort of data you're destructuring, what are the things that you can expect out, and how do you handle the null and undefined values. So how will TypeScript help here is, with TypeScript, our IDE can provide much more accurate suggestions for props, states, context. This reduces the amount of time we need to spend searching through the code to understand what variables or functions are available for us to use. So it will auto-generate the expected props for a component, making it much faster to code without constant reference to the component or the documentation itself. Now, with the understanding of these 4 key points, let's go ahead and set up a React application with TypeScript. So we'll be setting up a new React application using Create React App. If you're not aware of Create React App, there is a session that will be available in the information section of the video. Please go through it. There I have already covered the basics of Create React App for a JavaScript application in detail, in great depth. You will have an understanding of what files come out and what do they mean. And today we will be reusing and extending the same to create a new TypeScript application. We will use the TypeScript template of the Create React App. So why create React app? Because it makes the setup a lot easier and you don't have to worry about a lot of things. In future, as your experience grows, as you understand much more intricacies about the bundlers and compilers, we will go ahead and set up a new project from scratch using Webpack, TypeScript compiler, ESLint, all those configurations ourselves. But for now, to ensure that we don't make this too complicated, let's go ahead and dive into Create React app and create our project. So this time I'll create a generic application just to walk through the files and then we'll see. Okay, we'll create a new project here. So you can just shift and right click to open a new terminal here. Here is your terminal. And here, just like last time, we'll run the same command npx create react app @latest. Here, your application name will be TSApp for now. And then we are using the TypeScript template to generate this. Let's press enter. Here it starts to create a new application. It will install all the necessary dependencies for us. It will even set up the TypeScript configuration and the linting configuration that we would need for our project. And that's one of the reasons why we would initially, whenever you're starting out, we don't want to complicate the learning curve too much. By diving into the Webpack, TypeScript configuration, and other things very early on, let's try and understand the application first. Then slowly we'll understand what are the different aspects of the application we need to understand and dive in a little deeper and cover those aspects separately in detail. So this way, our learning is not impacted. You're able to build applications quickly. And this is something that is very scalable because Create React App is used by a lot of people. And here we have it. And here we can see it validated that this is a TSX file, which is TypeScript that supports JSX. And it created a tsconfig file for us. Let's go ahead and understand the application in detail now. I'll open this application in VS Code. And here it is. So up next, we'll try to understand the tsconfig file because that is the only file that is very different from what was there in our previous Create React app that we generated. Remaining all the files have already been covered as a part of our previous session. I will add the link to that video in the information section as well as towards the end of the video. Please refer to it for the remaining files as there is no change on the remaining structure. We are not consuming any different types, which we'll see towards the end. tsconfig is something that we'll dive into detail, understand every single config that is there in the current code that is generated, and we'll take it from there. Let's dive right in now. So what is tsconfig.json? tsconfig.json is a configuration file that controls how TypeScript behaves in our project. It specifies the compiler option as well as the file inclusion and exclusion for our TypeScript project. So here we are telling the TSC or TypeScript compiler that you should include everything that is under our SRC folder. Now let's understand some of the configurations here. You might not have the need to change them immediately, but it's always good to have an understanding of them. So what does target mean? Target defines the version of JavaScript to which the TypeScript compiles your code to. For example, here we are using ES5. So this compiles our code to ES5 syntax, making it compatible with older browsers as well. So even though you can use the cutting edge features in your TSX file, TypeScript compiler will ensure that it's compiled to a format which is available and compatible with all the browsers out there, even the older ones. Then we have our lib. So lib specifies what TypeScript libraries do we need to include. So we are including the DOM iterable, and ESNext. This operation or this configuration can be used to control what JavaScript features TypeScript already assumes are available for us to use. So definitely we will be using DOM in our application because we'll be dealing with window document. So we are telling TypeScript, okay, these are the features, assume that they are available to our application, DOM iterable, and then ESNext. So as we mentioned, ES5, it's the core definition for ES5 functionality. Then you had ES 2015, which is some additional features on top of it, ES6, 2016. And similarly, every year as JavaScript evolves, it adds new APIs out of the box. So like ES 2023, we have array.width, array.findLast, and other features like toSorted, toReversed available. So ESNext signifies that additional APIs will be available in ESNext. So everything that was there in ES 2023 and the ESNext, the next set of APIs which will be available. So this you don't have to keep on updating if you put ESNext here, because ESNext will keep on changing as the JavaScript specification evolves. The next feature is allow.js. As the name suggests, it allows JavaScript files to be imported inside your project, just like TS file, TSX file. So this should be set to true because you might create or you might have an existing JavaScript utility which you might want to include in your TS file, and this allows you to do that. The next one is skip libcheck. Skip libcheck. What does it do? It disables the type checking for declaration files, which is you might see .d.ts files or declaration.ts file. It can speed up compilation in large projects, but it also means that we might miss out on some type errors in the third-party libraries. By default, let's keep it to true because this is not something that happens very, very often. So up next is ES module interop. This property enables compatibility with common JS modules. Specifically, it allows us to use import syntax with common JS modules that have a default export, even though they might not be using ES module syntax internally. When is it useful? So without this setting, if you want to import a module which is plain JS or common JS module, you need, let me open up a new file to showcase. So without this setting, if you have to import a common JS module, you would write something like import star as module name from module. So this is the sort of structure that it has. But when this is set to true, we can simply write import module name from module. And you see, this is much less verbose and much more meaningful to implement. And that's why we set this configuration to true, ES module interop to true. Then allow synthetic default imports. So this one allows imports from modules that may not have a default export in their types. This is the setting which allows us to write import React from React, even if React uses named export internally. So strict set to true. It enables all strict type checking options in TypeScript. It is essentially a wide range umbrella option that activates several major rules for writing safer and more robust code. Some of the underlying rules that it enables are no implicit any. Every variable or function needs to have a proper type. It will throw error whenever you're using any as a type in your code. If you don't know about any, we'll come to it when we understand types a little more. So strict null checks is another thing that is enabled. It prevents null and undefined from being used in a way that could lead to runtime errors. Strict function types is the next property, which will ensure that a function argument and return types are correctly enforced. And then script property initialization. It ensures that any class properties, in case you're initializing, are either in the constructor or they have the default values appropriately. Very useful if you're dealing with class-based components in React project. I know they're not being used anymore, but there are some legacy projects which still use that, so it should be good. Force consistent casing in file names. I think it's very explicit what it's doing. It ensures that file imports respect the case sensitivity of file names. For example, import module from module, import module from module. If your file name is capital M with module, this will throw an error. That's what it does. Very useful. It needs to be there. No fall through case in switch. This prevents fall through case in switch statements, where a case statement does not end with a break or return. So it will automatically throw the error to ensure we don't unintentionally execute multiple case blocks. Then module. Module determines the module system that TypeScript should use when we are generating JavaScript. ESNext is the latest one. As we discussed already during lib section, ESNext is the latest ECMAScript module standard, meaning TypeScript will generate modern ES module syntax, import export in our outputs. So with this setting, our code is already future proofed and works seamlessly even when some of the things keep on updating with time. A little clarification for target and module. I've seen that this is a source of confusion for many people. So these properties serve very distinct purposes related to how TypeScript outputs the compiled JavaScript code. Both affect how TypeScript compiler transforms your code, but they focus on different aspects of the output. Whenever we are dealing with the target property specifies the version of JavaScript that TypeScript will emit when it is compiling your code. And then when we talk about module defines the module system that TypeScript will use for organizing your code during the compilation. You understand it? One is related to the organization of the code, the second is related to the output of the code. So while the output version of the JavaScript that comes out of this code will be compatible with ES5, internally that would be using ESNext modules to organize the code when compiling. So imports and exports and other things will be available for you during the time of compilation. Other common systems that are available here are CommonJS, which is the default module system for Node.js. And it is also widely supported by older versions of tools like Webpack. Then the next one which is available is ESNext, which we already have. Then we have AMD, which is asynchronous module definition, typically used in older browser environments or when we were using require.js. Then you have system. System uses system.js, which is a module loader that supports dynamic module loading. And then the last one is UMD, which means Universal Module Definition, a format that works for both browser as well as Node.js, the server-side environments. We don't have to dive too deep into this, but just a call out because I've seen module and target to be a source of confusion for many people. Hope this clarifies it, and we'll move on to the next property now. And then module resolution, node. What does this mean? It specifies how TypeScript resolves modules when using import statements. So node mimics the Node.js resolution strategy. So we are, as it is using node.js as our package manager, npm node package manager. So TypeScript looks for modules in node modules folder and then in the current directory and so on up the file tree. So that's how it goes whenever you declare a module. So first thing would be node modules and then your remaining file tree. It's the default and most commonly used module resolution strategy in JavaScript environments. Now, resolve JSON module. This allows importing of JSON files as a module in our TypeScript project, which means we can directly import any JSON file and TypeScript will treat that as a typed JavaScript. So if you want to consume mock data, it makes it easier to import JSON file directly and consume the mock data as it was declared in a .ts file. Then isolated modules. What it does? This ensures that TypeScript files are compiled independently of each other, making the compilation process much more reliable and easier to integrate with tools like Babel and others. If you're not familiar with Babel, Babel is a popular JavaScript compiler that allows us developers to use the latest version of JavaScript features like ES6, ES7 in our code, even with older browsers or environments that don't natively support them. It will take the responsibility of transforming modern JavaScript, any feature that we are using, into a version that can be understood by broad range of environments. So just a small thing to be aware of. No emit is set to true. So what does no emit do? No emit prevents the TypeScript from emitting a compiled JavaScript file as output. So instead, TypeScript will only perform the type checking and will not generate any .js file. You might be confused. Why are we using this then? Because in an application that is generated by Create React app, all the JavaScript files are generated by the Webpack internally. And we do not want our TSC or TypeScript to generate any JS files. It should only be used for type checking and the general compiler setup of our project. And this is the compilation module that will be used by Webpack as well internally. So explicitly calling out that, okay, I'm not emitting anything from here. And then the last setting that is our compiler option, which is JSX. So this option specifies how JSX code is transformed. React JSX uses the modern JSX runtime introduced in React 17, and this removes the need to import React on top of every file. If you do not have this, you would have to, whenever you're creating a new component, import React on top of it. But here, as you can see, even if I remove this, the component will not break and continue to run. It will not throw any error. And if I run the application run will be successful. Let me do that. So here we can see the application started and it does not throw an error even after React is not imported. And that's what this option is doing for us. So whenever you have JSX set to React JSX, React is treated as a global default. With React 17 and beyond, we do not have the need to explicitly import React just for JSX. This will enable that modern behavior and makes the JSX syntax a lot cleaner. So this was everything related to our tsconfig. Now we understand all the properties in detail. For remaining files, as I've mentioned previously, please check the course that would be there in the information section or will come towards the end of the video to understand all the remaining files in detail. In next, we will dive into TypeScript, some of the features, and understand how they come together with React components. Thank you for your time today. Hope this was helpful.